So we have here our example for investigation of singly reinforced beam. So given na meron tayong width ng beam na 300, yung beam depth na 500, then we have here the concrete properties. So FC prime is 30 megapascal, your concrete cover is 40 millimeters. And the steel reinforcement properties, yung diameter ng bar is 28, tsaka tatlo yung pieces or number of bars. Yung strength naman is Fy, 420 megapascal. And we have our factored bending moment na 266 kilonewton meter. So we're being asked to determine the design moments and capacity. So meaning isa-solve natin yung phi mn and investigate whether the beam is safe for flexure. So para maging safe yung beam natin sa flexure, dapat yung phi mn must be greater than or equivalent ito sa mu. So for our solution, first, determine muna natin yung required number of steel reinforcement. So yung provided na steel area is equivalent to the number of bars times pi d squared all over 4. So number of bars is 3, yung diameter ng bar is 28. So yung calculated na provided na steel area is 1847. After that, we're going to solve for the steel covering. So the steel covering is taken from the edge ng ating beam papunta dito sa centroid ng ating steel reinforcement. So to calculate this, first, we have to add our itong a clear concrete cover, C sub C. Then i-add natin dito sa diameter ng ating stirrups. And then sa centroid ng bakal natin dito, that is equivalent to bar diameter divided by 2. So CC times diameter ng tie plus diameter ng bar divided by 2. Yung C sub C natin is 40, diameter ng stirrups is 10, bar diameter natin is 28 divided by 2. So yung steel covering natin is 64 millimeters. After that, isi-solve na natin yung effective depth. So to solve for our effective depth, yung H natin na 500 millimeters, ay babawasan na natin ng steel covering. Kasi yung D natin is taken from the centroid ng ating steel reinforcement hanggang dito sa extreme fiber ng ating concrete sa compression side. So ito yung D. So yung H na 500 minus yung concrete na covering na 64, yung D natin is 436 millimeters. After that is yung minimum na steel area. So yung minimum na steel area natin is the maximum value between these two equations. So 0.25 times square root of FC prime na 30, Fy na 420, width na 300, then yung D na 436. Yung makalculate na value is 426. Next na equation, 1.4 divided by Fy na 420 times yung width na 300 times yung D naman na 436. Yung makakalculate is 436. So yung maximum value is 436. So ito yung na ngayon yung mag-govern na minimum steel area. After that, we're going to compare it sa ating provided na steel area. Since yung provided na steel area is 1847, greater siya sa minimum na steel area na 436, therefore okay. After that, we're going to assume na yung tension steel natin ay mag-yield such that yung Fs is equivalent to Fy. Then, we'll now be able to calculate the depth of our compression block na A to be equivalent to A as provided na 1847 times Fy na 420 all over 0.85 times Fc prime na 30 times yung D na 300. So, makalculate na A is 101.4180. After that is to solve for the beta factor. Since yung Fc prime natin is 30 megapascal, it is in between 28 at 55. We're going to make use of this equation. So yung beta factor is equivalent to 0.85 minus 0.05 times FC prime natin na 30 minus 28 divided by 7. Makakalculate na beta factor is 0.8357. After that is to determine naman the dedication of the neutral axis. So A lang divided by beta. So 101.418 divided by 0.8357. Yung calculated na value ng location of neutral axis C is equivalent to 121.3570. Then we're going to substitute this sa pag-solve naman ng ating strain ng ating extreme tension steel. So 0.003 times yung D na 436 minus yung C na 121 all over ang C na 121. So yung makalculate na strain ng extreme tension steel is 0.00777781. Take note, every time na mag-solve kayo ng strain na extreme tension steel, dapat at least 5 significant figures. 1, 2, 3, 4, and 5. After that, i-evaluate natin. Since yung strain is greater sa 0.005, meaning tension controlled. If that will be the case, yung stress reduction factor natin na phi is equivalent to 0.9. And then we have the strain naman. Since ang strain natin is greater siya sa 0.004, meaning ductile yung beam. So, okay. Next is yung strain is greater siya sa ating yield strain. Kasi kung i-calculate natin yung yield strain, calculate natin, yung FY natin is 420 divided by 200,000. So 0.0021. So greater yung ating strain ng ating extreme tension steel sa yield strain na 0.0021. That will be the case. Tension steel yields, meaning tama yung assumption natin na yung Fs is equivalent to Fy. After that, we're going to solve the nominal moment strength. So Mn is equivalent to As provided times Fy times D minus A all over 2. So yung S provided natin is 1847, yung Fy is 420, then yung A is 101, then just divide by 2. A larger value will be computed kasi yung unit nito is naka-Newton times millimeters. So we have to divide this to divide by 10 to the power of 6 para makuha natin yung value in Newton meter. After that, you multiply the nominal moment by the strength reduction factor para ma-solve naman yung phi mn or yung design moment strength na capacity. Since ang phi mn natin is 269, greater siya sa mu na 266. Therefore, safe yung beam for lecture.